students, I am Sunil Kumar, your math faculty. Today I want to discuss with you the next part of the lesson number 2, that is called polynomials. The next part of the polynomials. Before the next part discussion, I must say I hope you all are safe and you all are taking the prevention for COVID-19. I am also taking prevention for COVID-19. So stay home, stay safe, and today's our class, math class, is the definition of polynomial, the real definition. In my last video, I said you about the definition of the polynomial. A polynomial is an algebraic expression which carries the constants and the variables. I explained you what are the constants. Constants are called as the pure numbers, and the variables, the value we don't know. It may vary. So these are the this can be represented by the English alphabet, that is from A to Z, small letters. So after the discussion of the degree of the polynomial and the classification of the polynomial in the last video, the classification of the polynomial can be classified among two ways. One is called polynomials according to their terms and polynomials according to their degrees. After the explanation of the polynomial according to their degrees, that is degree 1 polynomial, linear polynomials, degree 2 polynomials called as the quadratic polynomials, degree 3 polynomials are called as the cubic polynomials, and degree 4 polynomials are called as the biquadratic polynomials. And already I gave you the explanation of all the degree of the polynomial formats to you. So linear polynomial, only one polynomial which can be expressed in one variable and can be expressed in two variables also. In our 9th class, degree 1 polynomial is in one variable, or linear polynomial in one variable only. So before that, today's my discussion point is to all of you is that after knowing the degree of the polynomials, we can add some few lines here for the definition of the polynomial. What I said to you, now polynomials are the algebraic expressions. So these are the pure algebraic expressions which constructing using the constants, using the constants and the variables. So they can be expressed by using the constants. I know you know constants are the pure numbers and the variables are the unknown things, the x, y, z, a, b, c, like that in English alphabet. So now another two lines I added here today for you. Very interesting. I am just saying it very slowly and try to understand nicely. What is said? Coefficients operate on variables. Coefficients operate on variables. So I want to explain you in my next phase what is coefficients operate on variables. Just try to understand the definition today. Which can be raised to various powers of non-negative integer exponents. This line is BBI, very, very important. What is saying? It can be raised to, which can be raised to the various power of non-negative integer exponents. So they are having the coefficients operate on variables, coefficients operating on variables. So coefficients are attached with variables. Try to understand nicely. Which can be raised. What can be raised? The variable power. Which can be raised. What can be raised? The variable powers. Understood? What can be raised? The variable power. Variable unknown thing. X, Y, Z. So that power. That means suppose I am saying x. I can say x to the power 1. So that is the power x to the power 1. X to the power 1. This is the variable power raised to this power. This power must be a non-negative integer exponent. Non-negative. What do you mean by non-negative? Non-negative is purely called as positive integers. As you know, integers are divided into two parts. One is called positive integers, 0 right hand side up to infinity, and 0 left hand side. Those are called as the negative integers or negative integers. So here the variable power must be a non-negative. That means a positive integer. The variable power must be a positive integer. It cannot be a negative integer. So the way it is written here, I will explain you again broadly I will explain you. Just you try to understand this today. After my next page, I will explain what is coefficients, operate on variables. That one I will explain, and also the power which can be raised to the various power of non-negative integer exponents. I will explain you later. So non-negative means positive. That means the variable power must be a positive one. It should not be a negative one. Negative means x to the power, if I am saying -2, if this type of powers are available in expression, suppose an expression I am giving to you and the variable power is a negative integer. It is a non-negative integer. That means it is a positive integer. But if the variable power is a negative integer, then they cannot be said as a polynomial. Very clearly try to understand. If the variable power raised to a negative integer, variable power raised to a negative integer, then they cannot be said as a polynomial. So polynomial, for the expression to be polynomial, the variable power must be a non-negative integer exponent. Non-negative integer, you got it? What is that non-negative integer? Positive integer. Right now, I hope you understood this definition. So again, read clearly. Let's go for it. Polynomials are the algebraic expressions. They are the algebraic expressions constructing using constants and variables. Constants, pure numbers, variables, English alphabet unknowns, small letters, small a, b, c, d, like this up to z. Coefficients operate on variables. This one I will explain you what is coefficient operate on variables, and which can be raised. Which can be raised? The variable power. Variable power can be raised to a non-negative power, non-negative integer exponent, or it should be a non-negative power. Then only that expression can be called as a polynomials. I hope you understood it. Now, I draw a table for you all to give an example to you. By example, you can understand it nicely again. Look at it. Some expressions are written for you. In this column, I am saying them as polynomials. So what is that expression? First expression is for me 2x. Next, the second expression for me is 2x plus 5. The third expression for me is 3x square plus 5x plus 6. The fourth expression is x cube. The fifth expression is minus 5y. So why I wrote this? These are all polynomials. Why? You will ask me, sir, why these expressions are called as polynomials? Look at it. These are algebraic expressions. It is right. Because they are consisting of the constants and the variables. Constants are 2, 5 here, and x is called as the variable. So they are consisting of constants and variables. So it is satisfying the definition of the polynomial, and also it is satisfying the second part of the definition of the polynomial. Look at it. Coefficients operate on variables. Now come to this point. I am explaining you nicely. Nicely you have to listen. See, coefficients operate on variables. So this is a variable. What is the variable? That is called x. So x is multiplied with whom? Multiplied with 2. Very clearly x is multiplied with 2. So what is that 2 called as? 2 is called as a constant or a number. So when it is in the expression wise, the 2 will be called, it is operating on the variable. It is 2 is operating on variable. 2 is multiplied with x. So if anything is operated on a variable, it may be a multiplication, it may be a division, like that. So in case of that, that is the multiple of the variable. What is 2? 2 is called as the multiple of the variable x. So variable multiples, try to understand the variable multiples. Again I am showing in the side the variable multiples. It is a variable. What is the multiple for the variable? 2. So this 2 is called as the coefficient. Coefficients. I hope you understand what is coefficient operating on variable. Look at this coefficient. What is the coefficient? Coefficient is 2. On which it is operating? It is operating on the variable x. So 2 is called as the coefficient of x. Okay. Now here you see in the third case, what is the variable? X. And what is it that? X square. So now you see, what is 3? 3 is operating on x square. 3 is multiplied with x square. So x square multiple is 3. So this 3 is operating on the variable x. So the 3 is called as the coefficient of x square, because x square is here. So x square coefficient is 3 here. Here you see the x coefficient is 5 here. Now I hope you understand it nicely. Here see, y is a variable. So what is operating on that? Minus 5. So what is the coefficient of y? No, minus 5. That is the line written here. Coefficients operate on variables. I hope you understand what is this line is about. That is, coefficients operate on variables. So which can be raised to the various power of non-negative integer exponent. Which can be raised? Which can be raised? The variable can be raised. Variable can be raised to the non-negative integer exponent. Non-negative integer means positive. I can write it to x to the power 1. Raised to the power 1. So 1 is called as non-negative integer exponent. Exponent means power. So x power is 1 here. Now here see x power is 1 here. Now here see x power is 2, x power is 1 here. Here you see x to the power 3. Here you see y to the power nothing is there 1. So right now for this reason they are satisfying my definitions here. These all expressions here are satisfying my definition. They are algebraic expressions which they are constructed with the constants and variables. Yes, they are constructed with constants and variables, and the coefficients operate on the variables. The coefficients you understood. X coefficient is 2, x square coefficient is 3, y coefficient is minus 5, and the coefficient power, on the variables which can be raised to the various power. Who can be raised? The variable can be raised to the non-negative integer exponent. Non-negative. See, here it is 1. So definitely 1 is called as the non-negative integer. That means positive integer. And if it is like this, I explained you now just x to the power minus 2 is there. So if the negative integers are there as the exponent or power, they cannot be called as a polynomial. Those are non-polynomial expressions. Those are non-polynomial expressions. They may be algebraic expressions, but they cannot be said as polynomials. Why? Because the variable power is a negative integer. Okay? I hope you understood. Let's go for some non-polynomial expressions by which it will be clear to you. I am giving some non-polynomial expressions. See now. So what I said, like that one expression is here. X to the power 2 plus 1 by x to the power 2. Can I say it is a polynomial? Here you will say, sir, they are constructing with constants and variables. Yes, here it is constant 1. So here it is 1 into 1 by x square. So constant and variable is x, and also separated by algebraic symbols plus. So it is algebraic expression. But can I call this algebraic expression as a polynomial? No. Why? Because x square plus I can write 1 by x to the power 2 according to the law of exponent. It is 2. 1 by a to the power m can be written as a to the power minus m. You already know about it in our 8th or 7th class. So it can be written as x to the power minus 2. Look at this expression. This is an expression. This is an algebraic expression. But it cannot be considered as a polynomial expression. Why? Because the variable power is raised to a negative integer. Here it is a positive integer. Here it is a negative integer. So definitely this expression is not belonging to a polynomial expression. Understood now? Clear? What are the polynomial expressions? What are the non-polynomial expressions? Polynomial expressions are always those expressions. They are the algebraic expressions. They are consisting of constants and variables, and the variable power must be a non-negative integer exponent. Then their exponent must be non-negative. That means positive exponents. I hope you understood. Now you see, there is a table for you. I did a table for you. Here I wrote some algebraic expressions, and those can be called as polynomials because they are satisfying the definition of the polynomial. There is no negative integers here, so all are non-negative integers as the variable powers. So now these polynomials, I have given two tables for you. Here two tables are there, and the table headings are according to their terms you have to divide them, according to their degrees you have to divide them. In my last video I said you classification of polynomials according to their terms and according to their degrees. So when you are going to classify them according to their terms, you have to see the algebraic symbols. Algebraic symbol means plus minus in between the terms. See now here nothing is added, nothing is subtracted. So it is a single term. What is single term called as? I said it, single term. It has been a single term, or it is called as, single terms are called as mononomials. It is called as mononomials. And when you are classifying this according to the degrees, we'll go later. Let's classify according to the terms first all. Next, what is this? Having two terms. See, it is separated by algebraic symbol plus. So my first term is this one, second term is this one. This second term is a constant here, pure number. So this can be called as a having two terms, and two terms are called as binomials. These are called as binomials. Okay. Now you see in this one first term, second term, and third term. Three terms are involved in it. So after the two terms, what I said to you to do, you have to don't write three terms, write here direct poly. Poly means many. Many terms. Polynomials. Polynomials. You can write like this, polynomials directly. So now here you see, here again after that to confuse you, I gave another one. So x cube. Nothing is added or subtracted. So here it is only one term. It is also the example of a single term or mononomial. Clear? Now you see this one is also nothing is added, but a minus sign is there. So minus sign is belonging to the number only. Minus is minus 5. Minus 5 is called as the coefficient of y. I explained you now coefficient. Coefficient is operating on the variables. So here variable is y. 5 is operating with y. So minus 5 is operating with y. So it is called as the coefficient of y. What is the coefficient of y? Minus 5. But it is a what? It is also a what? Mononomial. Mononomial, because having single terms. Clear? So now I already explained you the classification according to the terms by taking some polynomials, and see now when I will go to the according to the degrees. When I will go to according to the degrees, then what I have to see? What I have to see? Please answer me. What I have to see? I have to check the variable power. I have to check the variable power. So what is the variable power here? Here is the variable x. What is the power? 1. So it is called degree 1. Degree 1 polynomial. Degree 1 polynomial. Now you understood? Degree 1 polynomials are called as linear polynomials. See now, when an expression is having single term in called as mononomial, and when you are going to the power of that, it is just changing. It is coming under the degree 1 polynomial or linear polynomial. So these are the classifications according to the term and according to the degree. Similarly, here it is a binomial, but binomial in what degree? 1. Degree is 1 here. So it is also called as a degree 1 polynomial or linear polynomial. Linear polynomial. I hope you understood this. Linear polynomials. Now you see here three terms are there. Polynomial. It is a polynomial. Then you will say me, one thing you must ask me, sir, here variable is x, but having different powers here. x to the power 2 is available and x to the power 1 is available. Which one to take and how to say? The highest power. In my last video I said highest power, highest degree must be concerned. Highest degree is 2 here. So what is the highest degree? 2. So it is called as degree 2 polynomial. Degree 2 polynomial, degree 2 polynomial or quadratic polynomials, called as quadratic polynomials. Quadratic polynomials. I hope you understood. Now you see, this is also degree 3 polynomial, but it is a mononomial. When you will say according to term, it is a mononomial. But according to degree, the degree is 3. So degree 3 are called as the cubic polynomial. Degree 3 is called as the cubic polynomials. Clear? Now it is also having the y to the power 1. So y to the power 1 means it is a degree 1 polynomial and also can be called as a linear polynomial. If it is 4 will be there, then definitely they are called as degree 4 polynomial and can be called as the biquadratic polynomial. I hope you understood all of these things nicely. In my next part, I will start the next part of the polynomial. Now, let us see. One thing I want to say you, this is not in your book. This is for IIT book purpose only. So, extra knowledge for you. So, what is written here? See, expression, general expression for polynomials. When we are saying a polynomial, how can we say the polynomial up to the nth degree? Nth degree means the variable power when it will be starting from n. So, let's see. First of all, you have to know why I wrote here px and I gave a nb here. Nb means notice board. It should be note. So, what I said, na px. So, why I wrote here px? See, for example, I am taking a polynomial 2x plus 5. So, this polynomial is a binomial. This is a binomial having two terms in it and the variable power is 1. So, it is a degree 1 polynomial or linear polynomial. Okay. Now, you see, I am writing here px. Why I wrote here px? Because this polynomial is existing in x variable. So, I wrote here px. So, now you got the point px. Then, if the polynomial degree, here it is 1. But when it will start from nth degree, then how to express the polynomial in its general format. Very important. See now, it is starting from a0. That means the coefficient is nothing here. So now it is x to the power n. Then next a0 became a1. So what is a0 called as? The coefficient of x. a1 is the coefficient of x to the power n minus 1. Like that it is written. One thing you mark here, here the variable power is decreasing. N, then n minus 1, then n minus 2, dot dot dot, and x to the power 1, it is reaching 1. Then see, it is reaching 0. So the variable is starting from nth degree and ending at 0. So similarly, what should be the change you will you will observe? The change you will observe in the coefficients also. A to the a0, a1, a2, an minus 1 and an. So one thing you mark, while the variable degree is decreasing, there on the same time the coefficients are increasing. See, it is in increasing order. That means various types of coefficients are coming. So this is called as the general format of a polynomial. It is called as the general format of a polynomial of nth degree. Now it is not in your book, but it is in the 10th book and also available in IIT books. That much also I am saying to you to know, to go for the better explanation. Now you see, there is a note. What is the note I gave? A polynomial can be a multinomial. Polynomial can be multinomial. Everything are polynomials. Every expressions can be called as polynomials. A monomial is a polynomial. A binomial is a polynomial. A trinomial is a polynomial. And more than 3 or 4, it is called multinomial. So, a polynomial can be a multinomial. You can write monomial as a multinomial expression. You can write binomial as a multinomial expression. But every multinomial means more than 4 terms cannot be produced as a monomial, binomial or trinomial. Try to understand, every polynomial can be a multinomial. So mono, bi, tri, we can say them as multinomial. We can extend them as up to multinomial. But multinomials cannot be the monomial or binomial or trinomial. Very good point to remember. A monomial, a polynomial can be a multinomial, but every multinomials need not be a polynomial. I hope you understood these points nicely. Thank you very much.